Hey guys, this is Preetham, and today we are going to solve another problem in Project Euler. This is the third problem, which wants you to find the largest prime factor of some big fat number that I don't know. And now we are given a sample case here, which takes 13,195 as the largest as a number, and it gives you the four prime factors, and the largest among them is 29. Alright, and so let's try to read this number first. Not that it would matter, but I'm pretty sure this is way into the trillions, bazillions. Alright, it's about 6 bajillion. Alright, if you want to do it by hand, please go ahead and try, but by then you would have probably spent the whole time you would have been sleeping. Alright, anyway, let's get right into this. So we want the largest prime factor of this, and this is odd. So of course it can't have any even numbers, or for that matter, any large number to be prime cannot be even, because 2 is the only even number that is prime, so 2 is an exception. Alright, now given that, let's go ahead and get ready to solve this. So the first thing we want to do is define a max prime variable and set that to -1 to avoid any kind of bias. And now, before that, we gotta ask the user to input that. So input would be an integer input, by the way, and that would be an input of, alright, enter the number you want the largest prime number of. Alright, let's just keep a little space between that, 4 spaces, that should be good. Just avoid it being messy, and now we are just going to print input to check if this works. So let's see, that's 123. Alright, so this works now. Maybe 4 spaces was a little bit too much, so I'll just cut that down by 2. Alright, now that I know this input works, the first thing we want to do is weed out every single even factor inside this. So for that, we'll need to do this. While the number is even, so that is gotta be input mod 2, while the remainder of the number divided by 2 is 0. While that's true, please do this. We gotta make max prime as 2, and we gotta divide the input by itself, integer divided by 2, or shift it right by 2 by a bit, whatever you prefer. But that's that. And now, in our first case, I don't think it's even going to go through that while loop because it was an odd number. And now that we got all of this figured out, let's try, now we got to loop through the whole range of numbers. But we can optimize that. So let's say for I in range, right, 3 to math.square root. I kind of need to import the math library, but that's only to make sure that the runtime's better and not all inefficient. Or we could alternatively do it using the double star, which is the same as an exponent, but I'm just gonna import the math library because it's a little less code to write. Alright, so now every square root that you calculate just comes out in terms of a decimal, and I don't want that, so I'm just gonna cast it back to an integer. And now math.square root of input, and now that I got the upper limit, I want to loop over that number too, in case that happens to be 1 in a million of a large prime number. And so I'll need to add 1 to that so that I make sure to loop over that number, and now I gotta skip it by 2s because I only care about the odd numbers now, because the even numbers out there have been weeded out. There is no way an even number can multiply with another whole number to give you an odd number. Like, notice how I said whole number and not fraction or decimal. And now let's go on. So while I is a factor, we gotta make sure that this number cannot evenly divide the input. So we gotta make sure that while input divided by I produces a remainder of 0, we gotta perform 3 operations. Actually, it's just 2. But so the max prime would be set to I. And then, the number would be integer divided by I. So the input equals integer divided by I. And so this would just cut down the number by a whole score. And that would even help with the runtime, as ideally this would have taken a constant runtime with a few million operations. But now it's just cut down to a few thousands. Although it may not be significant, as the input gets larger, it really does matter. And now, even after all that cutting down, if the input, I don't know why I keep typing n, but that's maybe because I'm used to typing single letter variables, but just to keep it for professionality, I gotta type it so that everyone would understand. And now, if the number is still greater than 2, then the number's gotta be the largest prime factor. There's no doubt about that. If it happens to be the largest, prime number ever, I'm not sure what that is, so let's just stick with that. Now we gotta print that. Now else, we got another option where we can just return max prime, or print that, because this is not a function. Alright, let's test this code now. What number do I want the largest of? 13,195. The answer should be 29, as it was in sample test case right here. And now let's read that number down. 6008 5147 5143. So let's go there and try this code again. So that's 6008 5143, or was that 5147? Alright, 5147 5143. Alright, I was right. 5143. Now the largest prime factor of that is 6,857. That's it. This one is a lot more efficient than any for loop you ever want to do, because this one cuts down the runtime by a few scores and reduces the operations. I hope you enjoyed this, and please do let me know in the comments about what you would like to see in the future. Thank you so much, and I hope you have a great day or night ahead.